Have you ever really stopped to think about the air all around us? I mean, it's invisible, right? But it's also the single most important thing for life on Earth. It's this huge, complex, and honestly kind of fragile blanket of gases that protects us, lets us breathe, and gives us all our weather. So let's dive into this incredible system, our atmosphere. What we're going to do is take a journey straight up from the ground right under our feet to the very, very edge of space. We're going to explore what the shield is made of, travel through all its different layers, and get into the big challenges it's facing today. Okay, so before we start climbing, let's just look at the air we're standing in right now. What's actually in it? Now, here's something that might surprise you. The air we need to survive is mostly, well, not the part we actually breathe. If you take a clean, dry sample of air, a whopping 78% of it is nitrogen. And that's super important because it dilutes the oxygen, which slows down things like rust and fire. Then, of course, you've got the 21% oxygen that we and pretty much all life need. But what about that tiny little 1% left over? Turns out it's a really big deal. That last 1% is where so much of the action is. It's a mix of gases like carbon dioxide, which, plants need, and water vapor, which is the source of all our clouds and rain. It also includes tiny things like dust and ash, which can actually give raindrops something to form around. So the main takeaway here is even these tiny little amounts are absolutely vital. All right, let's start our journey up. You see, the atmosphere isn't just one big blob of air. It's actually structured into 4 distinct layers, and each one has its own thing going on. Let's start at the bottom. First up, the troposphere. This is our home. It's the layer we live in. It's the lowest, the densest, and it goes from the surface up to about 18 kilometers. Something like 75% of the entire atmosphere's mass is packed right into this one layer, all held down by gravity. And this really says it all. The most important thing to know about the troposphere is that literally all of our weather, clouds, rain, storms, wind, the whole shebang, it all happens right here. And as you go higher up in this layer, it gets colder. That's why mountaintops are so chilly. Let's keep climbing. Next up, we hit the stratosphere, which goes all the way up to 50 kilometers. The air up here is super thin and dry. And here's where things get a little weird with the temperature. It actually starts to get warmer the higher you go. Why? Well, it's all because of something called the ozone layer. So because there's no weather to bounce things around, this is the perfect layer for jet planes to fly in. It's a nice, smooth ride. But the most critical thing about the stratosphere is that it contains the ozone layer. This is a special kind of oxygen that soaks up most of the sun's dangerous ultraviolet radiation. It's basically Earth's natural sunscreen. Pushing higher, we get to the mesosphere, the middle layer. And here, the temperature flips again, and it gets cold, like really cold. It drops to as low as minus 110 degrees Celsius, making it the coldest part of our entire atmosphere. And this frigid layer acts as another kind of shield for us. This is where most meteors, shooting stars, burn up because of the friction with air molecules. And the tiny dust they leave behind can sometimes create these really cool wispy clouds way, way up high. Okay, we've finally reached the top floor, the thermosphere. This layer is just huge. It goes on for hundreds of kilometers until it just kind of fades away into the vacuum of space. And it's really made of 2 parts, the ionosphere and the exosphere. And some amazing things happen way up here. The ionosphere has these electrically charged particles that can literally bounce radio waves back to Earth. That's what makes long-distance radio work. These particles also get supercharged by the sun, creating those beautiful light shows we call the northern and southern lights. And above all that, the exosphere just ends. It blends right into space. So we've seen how all these layers work together to protect us. But our journey's not over, because this incredible shield is also vulnerable. Let's go back down to that all-important ozone layer in the stratosphere and take a look at the threats it's been facing. This is the famous ozone hole that NASA first spotted over Antarctica. Now, it's not a real hole that you could fall through. It's more like a region where that protective ozone layer got dangerously thin, letting a lot more of that harmful UV radiation get through to the surface. So what caused this thinning? Well, the main culprits were these man-made chemicals called chlorofluorocarbons, or CFCs. These were in everything from old refrigerators to aerosol cans. And when they escaped, they drifted all the way up to the stratosphere, where sunlight broke them apart, releasing atoms that just destroyed ozone. But here's the good news. This is a problem humanity actually got together and fixed. Through an agreement called the Montreal Protocol, CFCs were banned, and now the ozone layer is slowly healing. It's a pretty powerful example of what we can do when we cooperate. The ozone story really shows that our atmosphere is vulnerable, but it can also be resilient. Now we need to talk about another huge challenge. And it's so important to understand that this is a completely separate issue from the ozone hole. That was about specific chemicals eating away our UV shield. This next challenge is about different gases making our planet's warming blanket thicker. This diagram shows a process that's fundamental to our planet. The sun's energy comes in and warms up the Earth. The Earth then sends some of that heat radiating back out to space. But greenhouse gases in the atmosphere, like CO2, trap some of that outgoing heat, kind of like the glass walls of a greenhouse. And here's the thing. This is a good thing. The natural greenhouse effect is what keeps our planet at a comfy, livable temperature. Without it, we'd be a frozen rock. The problem is the enhanced effect. Human activities, mainly burning fossil fuels, have pumped an excess of these gases into the air, making that blanket thicker and trapping way too much heat. And this is the result. We're not just talking about a minor tweak to the planet's thermostat. Scientific models are projecting that this is the potential increase in the average global temperature by the end of this century. That kind of rapid warming is what we call global warming, and its consequences are, well, profound. So what does a warmer world actually look like? Why does this matter so much? Let's break down some of the direct impacts of this enhanced warming. The impacts are all connected. As ice caps and glaciers melt, sea levels rise, which threatens coastal cities. Weather patterns get thrown out of whack, causing more extreme droughts in some places and floods in others. This messes with our ability to grow food and manage our water, and it can even impact our health by letting diseases spread to new areas. This quote from the source material really puts it bluntly, and it highlights a really key difference in terms. Global warming is the temperature increase itself. It's the fever. But that warming is what drives the larger change in the climate, the long-term shifts in weather, sea levels, and ecosystems that affect every single one of us. So we end our journey right back where we started, with this incredible life-giving shield. We've seen what it's made of, we've traveled through its layers, and we've looked at the serious threats it's facing. And all of this leaves us with a really critical question to think about. This invisible blanket makes our entire world possible. So what's it going to take for us to protect it?